All right, so three variable system, but this time with substitution method. Okay, substitution method again is when it presents itself. Okay, so when we talked about two variables, we knew to use substitution because we had a coefficient of one for one of our variables, right? And that led us to it. So it's kind of the same thing here in the sense of, okay, is this going to be something I can easily substitute from the beginning or wait to the end? Okay, so step one is you want to make sure the equations are written in standard form. So it's still going to always be in standard form. That's our AX plus BY plus CZ equals D, our constant. Okay. Step two is to choose the equation that would be the easiest to get a variable alone. So key thing is the variable with a coefficient of 1. Still same thing as that. That's what we're looking for. Something with a coefficient of 1 to get the variable alone. Okay. You're going to substitute the expression into the other two equations and simplify to standard form. When you're simplifying to standard form, that means that you're going from 3 variables down to 2 variables. So the goal here is to get down to 2 variables. Okay. Then write the two new equations as systems and solve either using your own 2 variable way, whether it's elimination or substitution. Then you're going to substitute the 2 variables back into any of the original equations and solve for the last variable. The first substitution and solve for the last variable. And then you check your answer. Again, this is another method. It's just a way of practicing. Sometimes you'll see that it leans itself to do substitution versus elimination. And hopefully you're like, oh, okay, cool. All right. So up first, let me move my little menu. We have 2x plus 3y minus 2z equals -1. We have x plus 5y equals 9. And we have 4z minus 5x equals 4. Okay. What are some things you notice right off the back about this problem? I can get x by itself. One observation. Good one. Anyone else? Yes.
There's no y in the third problem.
There's no y in the third problem. And what else? There's no z in the second equation. Okay, so there's little things that we can notice. So first off, step one is to make sure everyone's in standard form. So standard form means that I have x, y, z. This one is missing a z, correct? So it's x plus y plus 0z equals 9. This one is not in standard form and it's missing a y, right? So we have a negative 5x. Remember, the sign stays with it. Plus 0y plus 4z equals 4. Okay. Now, the reason why we make sure in standard form is because once you put it in standard form, you can see, is it easier to eliminate or is substitution my best option? Okay. Like Riley said, substitution would be a good option, and that's because of this guy. That guy right there makes substitution an easy situation. The reason being is that I can easily get the x by itself, right? I can easily get x by itself, and each one of these equations, they both have an x in them. What's remaining? It does. So from there, we can go through and follow the steps. So we're in standard form. We're going to go ahead and do substitution because it has a leading coefficient of 1. So the first thing is to get this by itself. Step 2, well, sorry. Step 1, done. Step 2, we're now going to get x plus 5y equals 9 and get x by itself. What's the only thing I need to do to get x by itself? Minus 5y from both sides. So we have x equals 9 minus 5y. Okay. Step 3 tells us we're going to substitute this into the other two equations everywhere that there's an x. Okay. So I'm going to do it here. So I'm going to substitute x here. I'm going to substitute x in here. Cool. All right. So we have 2, but instead of x, we have 9 minus 5y plus 3y minus 2z equals -1. When we do substitution, I don't know how that came out. when we do substitution, that's where we do distribute, combine, isolate the variable, right? Distribute, combine, isolate the variable. So we're going to go ahead and DCI. Distribute, combine, isolate the variable. Distribute. It's a lot of movement. He just jingles. 18 minus 10y plus 3y minus 2z equals -1. I'm going to combine my like terms. So we have -10 and 3y makes -7. And then I need to move my constant. How do I move a positive 18? Subtract 18. So we're going to subtract 18. And we're left with -7y minus 2z equals 1 minus 18 is -17. Okay, so we got our first one. Now we're going to do it again. We're going to substitute it into another one. Yes. Did I drop my sign? Oh, good call. Good look there. You saw nothing all along. This is, yeah, what are you talking about, Brooks? And it's still a negative. That didn't go as smoothly as I thought. All right, so now we're going to do it again. And this time we're going to substitute it into the third equation. So the third equation, this guy, we're replacing x still. So now we have -5. And we're going to replace it with 9 minus 5y. Is it necessary to write plus 0y? No, it's not. So we're not going to write it. Equals 4. And again, when you substitute in, you're going to distribute, combine, isolate. Distribute, combine, isolate. Distribute, which gives us -45 minus negative. Yep, it's there. I need to finish my coffee. Equals 4. Okay. Is there anything to combine on the left side? No, we just got to isolate our variables. So y and z, what do I need to do to get y and z in their coefficients by themselves? Plus 45. So now we're down to 25y plus 4z equals 49. All right, so I'm going to show you guys at this point that you can use graphing, okay? No one said it, no one's brought it up, but at this point, once you're down to two variables, you can use graphing. The thing is, when you get down to the two variables in graphing, there's not going to be, it should be in the top back part of that file of my cabinet, at the top shelf. You're fine. So we're going to go to Desmos and I'm going to model it for you. The thing is, you have to be mindful that you can't put Z in necessarily, right? So when I'm here and I'm looking to see, okay, well, can you answer that while you're there for me, please? So if I put in 25y plus 4z, what does it do? It's like, oh no, you want a slider? No, I don't want a slider. So if I want to be able to graph it, I have to, in my mind, know that I'm substituting x for z in order for it to graph. Does that make sense? Huh. Is it for Shauna Jones or Crystal Jones? Give me a second. I'll go. All right. So if I do that, Now it'll graph it. But you have to know that you've put X in for Z. Does that make sense? So that's the only mental hiccup. You're not solving for X right now because you don't know the value of it. Yes. Okay. I was like, I don't know. I don't know. Something like that. You need her? All right now. Okay. Got it. You're welcome. So they were trying to say your name. They called you everything but yourself. Don't we hear a mother now? Miss Martin. In the counselor's office, so you go check it. No, take this fine. All right. So did we do it? Did y'all find the solution? Anyone? Okay. So then I'm going to do the other one. So the other one is, sorry for that in the recording. I may or may not edit that out. So I'm going to do negative 7y. What was it? Minus, but I'm not going to put in z because what happens? It has to, we want a slider. I don't want a slider. So we're going to make sure we put in x equals negative 19. Okay. So now I can come over here and it'll tell me what my z and my y are. Does that make sense? Yes. So from here, I know that z is 6 and y equals 1. Yeah. So step 5 is solving these two. You can choose to solve it algebraically or you can choose to solve it graphically, but you have to solve for those two. Yes? Doable? Okay. Then you're going to take those two and you're going to plug back into what you substituted. So you're going to go back to this step, equation, step 2. And now can I solve for x? Yeah, easy peasy, right? So x equals 9 minus 5 times y. And what is y? 1. So x equals 9 minus 5. Therefore, x equals 4. So my solution set is 4, 1, 6. Yay? Nay? Are we opposed to this? The key here is what tends to mess up is z. And you forget, like, and people are like, it didn't work. I couldn't make it work. No, it doesn't work if you put z in, okay? Anytime you have z, you have to let it be the x or the y, whichever one is missing. And just make a note to yourself, this is not x or y, it's the z. All right? Yay? Okay, let's try another one. It's going to be a word problem. So we're going to have to create it. We got to make the system ourselves. All right? So you manage a clothing store and budget $6,000 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? Okay. Just like any other time when you read a word problem, you need to identify your unknowns, right? What are your variables? So our variables here, we have t-shirts and we have t-shirts, and we can let that be our x, right? So we can let x equal t-shirts. We have polo shirts, and we can let that equal our y. And we have rugby shirts, and we can let that equal our z. Okay, so together, I know that I want to make $6,000, correct? So I want to make first part that I know is I want to make $6,000 selling these shirts. Because it's $6,000, that means I got to focus on the price of each shirt to come to that total, correct? So, t-shirts are $12. Polo shirts are $24. And rugby shirts are $36. Still with me? Okay. Next, I said that I want to restock 200 shirts. So I need a total of 200 shirts, which means that my t-shirts plus my polos plus my rugbies have to equal 200, correct? So that's X plus Y plus Z has to equal 200. Then it says I want to have twice as many rugby shirts as polo shirts. Okay, so I want rugby to equal twice as many polo. And now, did we just create a system? Yes. That's how you take the words from the problem and you turn it into a situationship here. Okay. Now that we did this, can we see why substitution is an easier method of solving this? Yeah, because one of them is already isolated first. We already have a substitution for our Z, correct? So everywhere there's a Z, we can plug in a 2Y and then go to the graph, correct? All right, so let's see how we do that. So I'm going to plug in Z here, and then we'll have our simplified equations, right? So we have 6,000 equals 12x plus 24y plus 36 times 2y. So that gives me 6,000 equals 12x plus 24y plus 72y. Keep going. And we have 12x plus, what's 24 plus 72? 96y. Okay, so I have 2 variable. Now I just need one more. So now we're going to substitute in z here, right? And that's going to give us our 200 equals x plus y plus 2y. Combine like terms. We have 1y and 2y make 3y. And here's our second. Conveniently, they're both x's and y's. So when I go to graph, I don't have to worry about it, right? All right, graph and find it. What's my x and what's my y? You can get here one time. All right. Let me pull up my little handy dandy. Guys, I want y'all to know how hard it is for me to show y'all how to do things on Desmos. Like, my insides are hurting. How quickly I want to grab Sylvie and be like, let's do it in Sylvie. But I'm adhering to the demands of College Board. All right, so 12x plus 96y, equation 1. Next one, 200 equals x plus 3y. If you were to do this in a regular handheld, you would have to get y by itself in order to find it, okay? Okay, I'm going to zoom out because clearly my numbers are large. And what do we get? Okay, so we have x equals, yes. Did I type something wrong?
No, I got 26.
Huh? Did you type in 6,000 equals 12x plus 96y? Did you type in 200? Ah, okay. Did-
Oh, it didn't change. I was the wrong one. Okay.
Oh, I was like, I don't know. Huh? Oh, okay. I was like, I don't know. I promise. All right, so we got 20 and 60 in terms of this problem. So we know x equals, we have our x equals 20, and x represents what? T-shirts. So we need 20 t-shirts. Okay. Y represents our, Y was how much? And that represents what? Polos. And now can I solve for Z? Yes, we can solve for Z because Z is what? Twice the 60, right? Which makes it 120 rugby shirts are needed. How we feeling? Still with me? No one's mad? No one's like, oh no, lady. That'll be a fun recording to listen back to with all the interruptions. They're gonna force me to edit. Ugh. All right. Okay. Before I let you go, fly little birdies, I'm gonna give you one, but it's gonna be a hard one because it's not already isolated. So you gotta decide which value are you going to use as your substitution, get it by itself, and then substitute it in. I would either use X or Y in equation one or equation two. If I was you, but no pressure. In all honesty, if you didn't want to do substitution, what could you do instead? Elimination. Would I force you to do substitution? So pick your poison. You want to try with elimination or you want to try it? You want to do substitution or go back to elimination? Go for it. Go do it. It'll be great. I'll wait. All right. So because this is on our substitution notes, I am going to practice substitution. But for the ones who did elimination, good job. That works as well. Did you eliminate Y or Z? Y. We got Y. Did anyone eliminate Z? No. Either way, did it matter which one you did? Nope, because they were all set for perfection. All right, so if we're going to use elimination here, for elimination, I'm going to use equation number one to isolate the x, okay? And I'm going to substitute x in everywhere else. Does that make sense? So I'm going to get x by itself. To get x by itself, I have to move a negative 2z and a positive 1yz, which means that I'm adding in, subtracting. So I end up with negative 4 plus 2y minus z. Okay. After I do that, now I'm going to substitute in wherever x is in the other two equations. So everywhere there's an x, I'm replacing it with negative 4 plus 2y minus z. So I have negative 4 plus 2y minus z plus y minus 2z. Okay. Then I have the next one. And it's going to be 2 negative 4 plus 2y minus z plus y minus plus 2y minus z equals 10. Did I miss a number? Coefficient? Now, fun fact. If you're going straight to decimals, there's actually no reason for you to distribute, combine, and isolate. If you're going to go straight to decimal, there's no reason for you to distribute, combine, and isolate. The only reason why you do it is so that you have less to type into decimal, which ultimately will create less error in general, right? That's the goal. However, if this is a slowing down point for you or a hesitation point, DCI is not necessary if you're going straight to Desmos, okay? But I am going to model distribute, combine, isolate, distribute, combine, isolate. So I'm going to distribute, and I'm going to be left with a negative times a negative is a positive. A negative times a positive is a negative. A negative times a negative is a positive. And I'm going to keep simplifying. I'm going to go ahead and subtract the 16 because it's going to go there. I have negative 8y and positive 1y. What's negative 8 plus 1? Negative 7. Good job. Okay. What's 4 minus 2? 2z. And 1 minus 17 gives me negative 15. So here's my first two variables simplified. I'm going to do the same thing here. Distribute, 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 combine, isolate. A positive times a negative is a negative. A positive times a positive is a positive. A positive times a negative is a negative. Plus 2y minus z equals 10. I'm going to go ahead and move my constant. To move a negative 8, I'm going to have to make it a positive. And I have 4y and 2y. 4y and 2y make? It's not a joke. It's not a question. It's a real question. 6y. Then we have negative 2z and negative 1z, which makes negative 3z. And 10 plus 8 equals 18. Okay, so I'm down to my two friendly equations. And again, I got to remember that when I go to the calculator, I can't put what in? Z. If I put Z in, it's going to tell me, you want a slider? No, I don't want a slider. So I have negative 7y plus 2z. Oh no! X equals negative 15. Okay. Then we have 6y minus 3x, aka z, equals 18. And it tells me that I get negative 4 and 1. It's not x equals negative 4. What is it? It's z equals. So we get z equals negative 4 and y equals 1. Can I use that information now to solve for x? Yep. So I'm going to take that information and I'm going to plug it into and solve for x. So we get x equals negative 4 plus 2 times 1 minus negative 4. And what does that give me? That gives me negative 4 plus 2 plus 4. What happens to the 4s? Cancel out, and we get x equals 2. So my solution set is 1, 2, negative 4. All right, at this time, I now have gifted you all the knowledge that I have on 3 variable systems. It is now your job to go forth and do greatness.